hope you're having a great day. In this video, I'm going to introduce to you the rich topic of differential geometry. Let's start off by defining a group of curves whose equations are in the same form but contain some kind of parameter which can take different values. Mathematically, we express this as a family of curves. F of x, y, t is equal to 0, where for every x and y, the parameter t takes some value. Notice here that there's just one parameter, but know that there could be more than one variable acting as a parameter. Let's take a look at a few examples. Number 1. Suppose we wanted to find the family of lines that are parallel to one another, each with gradient 1. Now, we'd start off with y equals x, wouldn't we? But it could be y equals x plus 1, or y equals x minus 2. They're all parallel to one another. So, let's start with y equals x. Remember, our y-intercept is not necessarily 0, so let t be our y-intercept, where t is a real number. So this is not in family form just yet, so I'm going to do a bit of rearrangement. Move the y over. Now one of our sides is equal to 0, so it's in family form. F of x, y, t is equal to x minus y plus t. And this describes a family of lines that are parallel to one another with gradient 1. Okay, let's look at the next example. So we've done lines. What about circles? Let's say we have a set of concentric circles with centre 0, 0. Now, our radius could be anything. All we know is that the centre is the origin. Hopefully, you know that the general equation of a circle with centre 0, 0 is x squared plus y squared equals r squared, where r represents the radius. Now, instead of r, we can use the parameter t to represent it. So, I'm going to just relabel that as t squared, and then move it over to make the right-hand side equal to 0. There we are. We've got a family. F of x, y, t is x squared plus y squared minus t squared. And a really important thing to note again is that t belongs to the reals and is also greater than 0, because we can't have a negative radius. Okay, now I'm going to extend this problem. Let's just fix the radius as 1 now, and consider the line y equals x. Say we want to find a family of unit circles, i.e. circles with radius 1, where the centres lie on the line y equals x. So, just to do a little picture, we've got something like this going on. And they can overlap, but just remember that the radiuses are all 1. So why don't we take a general point on the line? We know this is y equals x. So what about taking the coordinate t comma t? Remember where t belongs to the reals. Remember, this coordinate is also our general centre of our unit circle. So, let's find our equation of our general circle. We'll have x minus t squared plus y minus t squared is equal to 1. Think of it as translating the previous family of curves we found in question 2. Again, why don't we rearrange to get x minus t squared plus y minus t squared minus 1 equals 0. And that is our f of x, y, t. I really hope you enjoyed this video, and please stay tuned for my next video where I'll be discussing envelopes and evolutes. Thank you for watching. Bye!